Okay, we're going to go over inequalities with the absolute value function. They get kind of weird there. But the inequalities are a subset of the equalities, and there are 6 equalities. First one is the equal sign, everybody's favorite, and then the not equal sign, and then the less than, greater to, greater than, or greater than or equal to. So these last 4 are the inequalities. So let's go ahead and do a couple of problems. Here's the first example, and it's a less than or equal to. The absolute value of this has got to be less than 12. These are kind of basic. Just remember this, that whatever is inside the absolute value brackets has to be, when it gets pulled out, has to be less than 12. So anything that is less than 12, of course, less than positive 12, and anything that is greater than negative 12. By greater than, I mean closer to 0. That's how negative number works. The bigger the value, the closer to 0. So let's just go ahead and hammer this one out. First thing you do is you just rewrite it as it is, drop the absolute value bars. Just pretend that everything inside there is going to come out positive. But now you have to prepare, because if this comes out negative in here, the absolute value function is going to change it to positive automatic. So that's how you set these up. You simply just write it without the absolute value bars, and then go ahead and put another less than, and then whatever this number is on this side, just its opposite over here, okay? And then you simply just do a little bit of algebra by getting x by itself. So we need to add 6 to the middle term. We need to repeat that to all terms. That's what algebra does. Do a little bit of math. We get this. Now we need to divide the 2x by 2. That means everybody else gets divided by 2. So this is our answer. Now you can put this in set building notation, right? X such that x is between negative 3 and negative 9 and positive 9. Not inclusive, right? Exclusive. Or you can use the interval notation, which is much easier, right? Negative 3 to 9. Do not use the negative 3. Do not use the positive 9. So here's another example. You'll notice that there is a negative sign in front of the variable this time. These behave a little bit differently, but they start out the same. You simply rewrite it without the absolute value bars, and then you're going to put the negative 24 on this side with a less than or equal to sign. You're going to add a positive, or I'm sorry, you're going to have a negative 4 to isolate the variable. You're going to do that to everybody. You're going to do a little bit of math. Now you get this. You have to divide the r by negative 2. Okay, there's a big red warning here. That's why I used red letters. But let's go ahead. We're going to divide everybody by negative 2, and we're going to get kabam. But there is a giant rule with inequalities, solving for the x's or the variables, is if you multiply or divide using a negative number, you have to reverse the inequalities. I'll say that again. If you multiply or divide with a negative number with inequalities, you need to reverse the direction. And we did. We divided by negative 2. So we reversed the direction of the inequalities. And now it looks funky. We got it basically in backwards order, but let's just reverse it a little bit. And that comes out to be the same thing. And in set notation, we just use the brackets because we can include those.
So that was an example of a less than inequality. So the less than or equal to, the general rule is, looks like this: any absolute value that is less than a specific number is equal to, the first step is just drop the absolute value bars, right? So anything within that is just less than C. That's the first part. And the second part is you flip the sign and change the C to the opposite of C. That was so important, I'm going to repeat myself. So the absolute value of anything that's being less than or equal to is 2 parts. The first part is you simply drop the absolute value bars and you just solve for less than C. The second half is you flip the inequality sign and then change C to the opposite of C and solve for that one. And of course, there's a second set of rules if you're dealing with a greater than inequality. And it looks like this. So if you have an absolute value that's greater than C, first step, just like the other one, you simply drop the absolute value bars and then you solve for greater than C. The big difference between this one and the other one is this is an or statement, okay? So solve for X is greater than C without the absolute value bars, or flip the equality sign and then solve for whatever's less than the opposite of C. Again, this is so important. I'm going to repeat myself. So if you have an absolute value inequality that's greater than, first step is drop the absolute value bars, solve for whatever's greater than C, or flip the inequality sign and solve for whatever the opposite of C is. Okay, you got it? All right, so we're going to do an example of a greater than. There it is. The absolute value of 2x plus 4 is greater than 12. First step, drop the absolute value bars, solve for x that's greater than 12. That part is always easy. It's always the second part. Now remember, this is an or. So the or is we're going to flip the sign, and then we're going to go ahead and change 12 to negative 12. So now we have to solve 2x plus 4 has to be less than negative 12. So we got two functions going on at the same time. But they're both very, very easily to fix. So let's just go ahead and solve them. So the first one, minus 4 is 2x has to be greater than 8. So x has to be greater than 4. Let's do the bottom one. So I minus 4 from both sides. I got 2x has to be less than negative 16. X has to be less than negative 8. Okay, so those are our answers, but I'm going to give you a real quick double check. So if you look at the number line here, x has to be greater than 4, so that means it's to the right of the number 4, but it has to be less than negative 8. So you got this big empty space right in the middle of the number line where the numbers cannot be used. So pick one of those numbers. I'm going to pick 0 because that's the easiest number in the universe to work with. So if I let x equal 0, I got 2 times 0 plus 4, which is 4. The absolute value of 4 is not greater than 12. So that little chunk of numbers right there I cannot use comes out to be double checked.
That's it. MGZ. Oh.